All right, so chapter 4, the infamous joining tables in a select statement. Okay. All right, so we don't just call databases, we call them relational databases. And it's because we can relate two tables together. In this example, you see, we want to see what the relation is between customers table and orders table. And the way we do that is by creating relationships within this table. So for example, instead of putting John Smith, Sue Doe, and Dave Brown into here where we might misspell their name, we actually relate them by their primary key and foreign key. So in this case, the primary key is customer ID in the customers table. And the orders ID is the primary key in the orders table. But the common field between these two is what customer ID. And they don't necessarily always have to be the same name, but for the most cases in our class, you'll find that they are the same name. So the primary key in this case would be in customers table, and the foreign key, meaning foreign to this table, would be customer ID. And we call this a one-to-many relationship. Remember how we talked about that? So tables can either have a one-to-one relationship, a one-to-many relationship, and a many-to-many relationship. But in our case, we're going to be concentrating when we do joins on a one-to-many relationship. And this creates what we call referential integrity. Okay. And in other words, we don't want to be able to put a customer ID in that's not already in the customers table. So our order, we would add the customer first, and then we would create any orders for that customer. Make sense? Of course it makes sense. I mean, how could you add a customer to an order if you didn't already have that customer in your database? So that's a one-to-many relationship. So one customer can have many orders. And with referential integrity, we don't want to be able to delete orders. We don't want to be able, we don't want to be able to delete a customer who has existing orders. And there's a way to do all that. Now, there's different types of joins that you're going to need to know. One of the biggest, the primary way that we join records are something called inner joins. Okay, and that's where there needs to be matching customer ID and foreign primary ID and foreign key in the tables. Okay. And it's where they intersect is usually the rows that we are looking for in an inner join. If they don't intersect, then we don't want those rows. Yeah. This shows how that relationship might look. And basically, these are, we found the intersection between those rows, and we are pulling those rows back. Now,
would the ID be the intersection?
The ID, the customer ID is in two different tables. And here's how that statement would look. We say where from customers, and then inner join orders from customers and then orders ID. Okay. So let's try this in SQL. Okay. So we got a customers table and we got orders table, right? And let's do a new query window. Now, we'll start off real simple. Asterisk from orders. And then we're going to do a select asterisk. Asterisk means all from customers. Let's go ahead and execute both of them. So we can see that order ID, and then this would be our foreign key right here, relating back to the customer table. And so let's say we wanted all the customers, we only wanted to see orders from customers that had a last name that began with S. So we could say something like this. Last name. We'll say like. I want you to get used to using the like. S %. All right. So we see only the customers that begin with S, right? Now, let's say we wanted to see all the orders for all the customers that begin with S. Then what we would do is we would simply do, whoops. We already know that these are going to return to customers whose last name begin with S, right? So I'm going to start qualifying my data because I'm going to be using two different tables. And this is where we start to do the joins. Okay. And in this case, we're doing an inner join. By the way, we don't need to use inner. It defaults to inner join, but we'll use it just for the fun of it. Okay. We don't need from. Inner join, we need the table name, customers. And then we use a verb called on. You don't have to capitalize it. You're going to look at the primary key. It doesn't matter what order you put this in, by the way. That customer. So where the customer ID in the customer table equals customer ID in the orders table. Okay. Oh, I guess I need to spell it right. And then we can put in this statement. And we're going to qualify this even though we don't need to because orders doesn't have last name in it, but we're going to qualify it. And that is your first join statement. And if we wanted to verify that that was true, we can actually put in customers dot last name. So these are all of our customers that have a last name of us that have an order, that have placed an order. Okay. Any questions about that?
Professor, so what exactly was joined? Like, what's the intersection you were talking about?
These two rows intersect, where these two columns intersect. So what we're saying is that there needs to be a customer ID in both the customers table and the orders table.
So that column, the customer ID column, would be that intersection.
Yes. And that's,
Okay.
yeah. Learn. If there's one statement you need to learn, it's this one. This is vital to SQL Server. Okay. So learn, understand this statement right here. This is a primary key in the customers table. This is a foreign key in the orders table. Now, how do I know that? Well, there's different ways to know that, but you can always look at your database diagram. Okay. And if you want to see where how they are joined together, create a new database diagram by right-clicking on database diagrams. And you can select orders and customers. Add those tables. Okay. And then this will tell you how the two tables are related together. Okay. And if you look, you can see we're going to make it easier to see how that looks, but there's a relationship created there. And just to see what the relationship is, you go into properties. And let me just bring this out. And we could look at the table and column specifications, expand that. So it tells you the foreign key base table, which is orders. The foreign key column is customer ID. The primary key base table is customers, and the primary key column is customer ID. Now remember, these two columns don't have to be the same name. They just happen to be, for the most part, in our class. So really in this class, it's just looking for that common column name a lot. Okay. And we don't have to save this. I just wanted to bring that up so you can know how to do that. All right. Let's go back to our notes. So we did this statement. And again, when it's an inner join, it doesn't matter what table comes first and what table comes second. And it definitely doesn't matter when you do the on. Okay. Now, that leads us to an outer join. Now, an outer join is different. What you can do a left, a right, or a full outer join. And we'll look at. So a left basically in this statement says, give me all the customers and only the orders where they match. If they don't match, it's going to return null. Okay, and I'll show you that. Another example of a left join. This time we switched to order the tables and saying, give us all the orders and only where the customers match. Okay. And if you have referential integrity set up in your database, you should never have this. Okay. Now, right outer join is just basically the opposite. It says instead of starting, it says give me all the customers to the right and only the orders on the left that match. See, and you can see the order is different. Okay. So in theory, this is a table on the right. This is a table on the left. So this time it's just going the opposite. And I'll give, and then a full outer join is basically give me all the rows from customers, all the rows from orders, and return null where they don't match. And we're going to try all three of these. Then you're going to rarely use full outer join. And I'm going to make a suggestion that you just stick to left outer joins. Okay, so let's see how that looks. So if I make this a left join, and you don't have to put in outer, but I will for this case. Let's see how that looks. And in this case, because we have referential integrity, it looks exactly the same. Okay. Well, let's switch the order of these tables around. Let's make this customers. I guess I probably should spell it right, correct? And let's make this orders. Notice I'm still using the left outer join. I didn't have to switch any of this stuff around, doesn't really matter. But watch how my statement, that my result set changes by doing this. So it does give me the 3 matches, okay? But wherever you see nulls, all nulls for the orders table, that means that these customers do not have an order. And I've returned 59 rows. Okay. So you see the difference, whatever table comes first is important. All right. Now, if I do a full outer join, I should get 59 rows again. And the reason I get 59 rows is because I do know that these tables have referential integrity. That means that anything in my orders table will have a customer row in the customers table. Now, it's also important to point out, you don't need to put outer join and you could put left join, and SQL knows that it's a left outer join. And we don't even need to put, and if we're going to do an inner join, we don't need to put anything in because it defaults to inner join. We'll get back to our 3 rows. Concentrate on the simplicity of what I've just did, okay? This is what you want to learn. Don't try to get super complicated right away. You're primarily going to have 2 types of joins. Inner joins, where it means where both tables have an intersection of that column of customer ID. And a left outer join where you're saying, give me all your customers, but only the orders that match that, and return nulls for all the ones that do not match. In other words, there is no customer ID in that orders table for that subset. Keep it simple. Put your joins on separate rows, okay? You're going to, and a lot of times what I want to do is I want to indent the joins. And if I have another join, because you can join many tables together, okay? You know, in this case, it might be order ID, items. And that would be joined on orders dot order ID equals order items. Okay, and then we can look at all the order items also. And basically what this statement does is brings in another table, and how SQL works, it first does this join, creates a new table, and then it does this join with the previous 2 joins and creates another table. Okay. Pretty simple how it works. Put your joins on separate items for each table and you will be good. Okay. Because it also allows you to test. So I can test. And then I go, okay, that works. And this is really how SQL thinks. And then you can test with the additional table. All right. Now I would ask us if there's any questions, but at this point, I suppose many of you feel confused. Am I correct?
100%.
All right. That's why we're going to do practice. We're going to practice a lot on this, okay?
Mm-hmm. Okay.
So your mind automatically doesn't think like this. Now, the last example was an inner join. It's always an inner join if I don't put left or right or full or outer. Okay. All right. Let's go back and confuse you a little bit more. How's that? All right. Now there's something called self-joins. Oh, what's a self-join? Well, self-join is when a table is joined to itself. So let's take a look. There's an employees table that actually joins it to itself using the supervisor ID. And I need to show you this, okay? Don't worry about this one. This one's a little bit confusing. Let's take a look at the employees, okay? So let's bring up another window here. That's not the one. Let's look at Northwind. In Northwind, you see this table called employees. I want to show you something interesting when I do a database diagram. Again, if you have referential integrity set up and you've set up relationships within your database, you can go to your database diagram and see what those relationships look like. And in this case, we're only going to add one table, employees. Okay. Close it. And you see this little box here. And basically what that box is telling us is that this is a self-join. In other words, the primary key of employee ID is related to some other column within this table, okay? And in this case, it's reports to, okay? So, but I just know that because it makes sense, but let's take a look and see what that looks like. I'm taking my time with this. I don't know if we're going to make it through all the notes, but let's take a look at this. And again, you see the primary key table is employees. The primary key column is employee ID. Okay, that makes sense. But the foreign key table is the same as the primary key table, the employees, but the column is different, reports to. So let's see how that looks. Okay. Let's go ahead and shut this baby down. You don't need to save it. We're going to open up a new window because we want to use the new database. Again, we can use the use, but we'll just select Northwind right here. And asterisk from employees. If we run this, we see all the employees. But the interesting thing is we see this reports to, and we see somebody doesn't report to anybody. This is not true. But anyways, they must be the big boss. And they are. So let's say we wanted employee last name. Comma, first name, comma, title. All right, so that's good. Let's go ahead and run that. That tells us all of our employees. All right, but now we want to see who they report to. So what we have to do is we have to start naming putting aliases for our tables names. And remember, we can use as, but we don't have to. I'm going to not use as, so I'm going to just call this EMP. I'll just EMP, and we can quickly put all that in here. And again, this will work fine. We know that. So just to show you, yep, no problem. But now we want to join in our reports to employees. So again, we're going to do a join here. We're going to join employees. But this time we're going to call it SUP for supervisor. And we're going to join on EMP dot, what is it, employee ID. Let's take a look. Employee ID. Of course, I know I spelled that wrong. Okay, so it's on, not of. Equals SUP. But this time we're not using the same name. We're going to use reports to. Oop. Okay. And in this case, because one person doesn't report to anybody, we're actually going to get one fewer row. So we can see that. We got 8. And the way you tell who they report to, you do something like this. Okay. And this time we're going to use SUP for supervisor. And we're going to say supervisor last name. We're not going to worry about the first name, but we will do the title. And this is going to actually tell us who everybody's supervisor is. And we could use as, it doesn't matter. Okay. Now, if we run this, we're going to see everybody's supervisor, except for Mr. Vice President. Okay. Because everybody reports either to him or to the sales manager. Now, if we made this a left join, it's going to show us everybody. Okay. But we really don't want that. Really want this. We want everybody who has a supervisor. So this is how you do a self-join. A self-join basically means a table joined to itself. All right, let's see how much more time we have. So another example of a self-join. You need to understand this, that every time you do a join, it creates an interim table. So every join is an interim table. Okay. And so basically when you do join invoice line items, there's actually a table already created from this. And then likewise, there's a table created from this that it's joined to. That's how SQL thinks. It's important to know how SQL thinks. Another example of an interim table. You know, the join clause there's implicit and explicit. Let me make a suggestion to you. Use an explicit syntax. Okay, that means use joins. Don't use this. You get confused. This is how we used to have to do things before there was a join statement. Okay, they both work, but use the join clause. All right. Use explicit. Don't worry about cross joins. We'll rarely do those. You can read up on that. Unions, oh boy. We will explain unions better as we go along, okay? We're not gonna have enough time to go through that. But the thing to understand about a union basically makes your result set longer vertically, where a join makes joins make your result set wider. All right. And we have a lot to learn about unions. You're going to use accept or intersect. You can use that. We'll do very little with that. Probably won't be on the test. But this will show you how this works. And intersect, of course, is where the two tables intersect. Okay. You can read your notes for that. One last example. Please go through this. If you have time, do your lab activity. I actually put those out there in Moodle. Right. Again, you could using the database diagram so you can see the intersections. All right. You don't have to worry about this. All right. Homework for next week. I want you to do practice lab 4 for next week. I'm going to make it available to you right now. And again, turn it in before class. So next week is the 24th. And if you have any questions, if you can't load SQL on your computer, you need to let me know and we'll set up time to go through that. All right. I know this is a lot of stuff. Go through your practice lab and try to do this. You can also do the exercises, which I'll make available. I'll even show you the solutions for that. Okay. So you'll have the solutions. As soon as everybody turns in practice lab 3, I will make this available to you also. Any questions with a minute to spare? Again, I don't want to downplay how important this chapter is. It's probably the most important chapter to understand. So I hope you spent a lot of time with this. It gets easier from here. Once you understand joints, life does get easier. Yeah, practice lab 3 is due today. It should have been due before class, but I'll give you some grace on this, especially if you haven't been able to load your SQL Server on your computer. So normally practice labs are due before the class starts because I go over them. Okay. In other words, I don't want you to be able to just copy what I say. All right. A lot of stuff, I know that. But we'll make it through these next couple of weeks and we'll be good. All right, sound good? Is everybody sleeping?
Yeah, sounds good.
All right. All right, so I will see you next Tuesday. And again, you submit your homework by emailing me your script. So you'll create a .sql script and you'll just email it to me as an attachment. Just, yeah, get practice lab 3 done, okay? Normally it's due before class, but just get it done. All right, thank you. Send me emails if we need to work on getting SQL Server loaded.
Perfect. I'll send that right now.
All right.